we've had a couple minutes to look at that. Let's just call on some people. Tell me what you did. So, Mikkel, tell me one thing about this graph that you were able to figure out.
Well, the x-intercepts are -2 and -4 because we later factored into x2 and
Awesome. So you factored and got the x-intercepts for -2 and -4. You guys agree with that? Yeah? Awesome. Thanks, Mikkel. So we'll go to -2 and -4, and there we go. Alright, cool. So there is something we know. Okay, let's go to Chloe. Tell me something else, Chloe. Awesome. So cover the x's, 8/3. And what is that? That's like 2 2/3. So I'll come up here and go to 1, 2, and about 2/3. There's our y-intercept. Okay, cool. So we've got our intercepts down now. Magdalene, can you tell something else about it? There we go. So the line x equals -3 is a vertical asymptote, because that's what would make the denominator 0, right? I'm going to come over here to -3. Okay, and there's that. So then the last one on here is our oblique asymptote. Ofa, how are we going to get that? Awesome. Tell me how you did that. So first off, what's the number we're going to have outside the box? Great. Keep going.
inside is 1, 6, and 8.
Okay, so we'll always bring down the 1, then what? Okay. Awesome. Now, what's the only part here we worry about? Good job, because this is my remainder, constant x. And we don't care about the remainder, isn't that nice? We just want the line y equals x plus 3. Is that what you got? Thanks, Ofa. So now I'm going to go and let's graph that. So it's kind of like the last one we did. It's going to have, let's figure out the y-intercept first, which is 3. It's right about here. And then our slope is 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, now this one's going to be a tad bit different. On our last example that we saw, we kind of filled in on the inside, right? It was almost like a tilted hourglass, if you think of it that way, okay? But this one, we're not on the inside. Where are we going to be? Outside. We're still going to be following along from one asymptote to the other. So, but this time we're going to be on the outside. So we're going to go along the top of this oblique asymptote, and then we branch off and go up like that. And then over on the right side, we're coming up from -infinity, and it goes like that. Can you visualize what's going on there? Maybe it'd be easier if we start on the right side, because it's easier to see, because I've got an x-intercept here and a y-intercept there. So it's going to follow along on the outside. So let me draw that in first. Does that make sense how it would go from one asymptote to the other like that? Now, using what we know about vertical asymptotes, here at where is this -3? On the right side, it's going down towards -infinity if we approach -3 from the right. But if we approach it from the left, what should happen? It's going down on this side. It needs to do the opposite, goes up. So that means it's going to start here and then come along like that. Alright, how are you going to check your work here? Desmos, or if you have a graphing calculator, do that. But it'll look something like that. And there you go, there's your graph. Do you have any questions on that? Go ahead, Josh.
The last one you're on the inside and this one you're on the outside. How did you figure that out?
Awesome question. So the way you're going to know if it's on the inside or the outside is you're going to look at your intercepts, your x and your y. So on the last example, the x and the y intercepts, they were on the inside, like right here. Okay? But the way this other example worked out is that the x-intercepts were on the outside. And so that's how you just kind of pay attention. And if you still can't tell, then you can just plug in points until you get an idea. It's kind of like, you know, when you did connect the dot picture games or whatever. It's kind of like that. If you don't have enough dots, well then just plug in points till you get more dots and you get a visual of what's going on. Does that help at all? Okay, awesome. Okay, let's do a couple of problems here. Take 10 seconds, I want you to factor that and see what happens. Go. Alright, Charlie, were you able to factor that? What does x squared minus 9 factor to? Good job. Now that we've factored that, what can we do here, guys? What do you notice? We have something that's a factor in the numerator and the denominator. So what I'm going to do, I'm going to cross that out. Okay? However, there's a problem here, guys. Even though I cross this out, you can't just forget about it. You need to remember it because it's going to show up in your graph. When you cross out a factor, this actually is going to turn into a hole in the graph. I think we talked about that for just a brief second last time. But if you cross it out, this means that there's going to be a hole at whatever would make that become 0, which is 3. So I want to say there's a hole at 3. Now what does that mean? Well, I'll get to that at the end. What we're going to do is we're just going to graph this thing just like normal. And then we're going to put a hole in it, okay? Okay, so now that we've factored and we simplified here, this is now just 1 over x plus 3. That should be a relatively easy graph to graph, okay? Let's just go over the basics of it. What are the x-intercepts, y-intercepts, vertical asymptotes, all of that fun stuff. Let's start with Izzy. The x-intercepts, where do we normally look to see that? Yeah, now the numerator is just a 1. So I'm thinking, what could I plug in here to make that become 0? And nothing would make that become 0. So what does that tell you about your x-intercepts? There's no x-intercepts, right? Because you can't make that become 0. So we're going to say, I'm just going to put none, because there are no x-intercepts. Alright, so that was helping this out a little bit. Brinley, what about the y-intercept? What do we do there? Awesome, so we plug in 0, and you get 1/3. So we've got a y-intercept at 1/3. About there. Alright, so then, Micah, what about the vertical asymptote? Awesome, and that'll be a vertical line, so I'll do x equals -3. So I'm going to come over to 1, 2, 3, and I'm going to put a dashed line here. That is my vertical asymptote. Alright, and then Kimberly, last one, how do we figure out what the horizontal asymptote is going to be here? What did you say? So if we had the degree of the numerator was greater than the denominator, then we wouldn't have to divide. But is that what we see on this one? No, so if we go back to our guide, let's go to page 3 on our guide. We've got those 4 scenarios. What's the first one there, Kimberly? Is that what we have here? Awesome. So the degree is 1 in the numerator, 2 in the denominator. 1 is less than 2, so we'll have y equals 0. Alright, let's talk about the right side here first. Either we're going to have an L or a flipped L, kind of like our ninja star shape, right? Is it going to be above or below? How do you know it's above? There you go. We've already plugged in a point, and it was positive, which tells me all the points above, all the points over here are going to be above. So let's just graph that. I'm going to get out a pen. It's on the right side. It's above. Well, then what does that tell you about the left side? It's below, because if it's going up on this side, then that means it's going down on the other side. And there you go. Hey, this looks familiar, right? This is just 1 over x. Show me 1 over x with your hands. Your ninja star, right? However, what will this do? What does adding 3 on inside of the function do? Moved it which way? Left 3. Remember how when you're adding or subtracting inside, you do the opposite and moves it left or right? Yeah, this is just 1 over x, move 3 to the right. And there you go, that's your graph. However, Beyonce, what were you going to say? Yes, so we're not quite done yet. What we need to do is go back and remember there is a hole at 3. So what we're going to do is I'm going to get my eraser out actually. I'm going to erase, we're at 1, 2, 3. Yeah, I said erase. Come on now. And what I'm going to draw there instead, and I usually use a different color so it's more noticeable. I'm going to put a hole in that graph. And make sure it's an open circle so that they know we're not including that point. So it's going to look just like 1 over x plus 3, but since we crossed out this x minus 3, we're going to have a hole at 3, so it looks like that. Okay, do me a favor, go to page 2. Is it on your notes? Flip that over. I want you to look at your guide at page 2, and I want you to just glance over that. Take about 30 seconds to glance over that. That's an example of one with a hole. And you should see it's pretty similar. You factor, you cross something out, you graph what's left over, but put a hole at where what would make that factor become 0. Once you've looked that over, I want you to try doing this next one on your own, okay? So look that over and then do this example on your own.